Alright guys, so as we continue with our 10.1 examples, using what we just went over, so the circle basics, as I have here, and my theorems, these two in particular are going to be very important in these examples. So we're going to go ahead and do a few examples just to see if we are understanding what we're doing. So we have, is ST, this is a circle. Let's start off with our circle centered at P. Is ST tangent to circle P? Well, this one right here looks very similar to theorem number 1, right? And so remember, it said that a line can only be tangent if and only if the line is perpendicular to the radius at its endpoint. So that means this can only be tangent if it's perpendicular to this radius here. So how would I check that? Well, if you remember, right, I can use, so it's a right triangle, so I can use a Pythagorean theorem to find out if it is indeed a right triangle, or it makes a right angle here. So I'm going to go ahead and do st squared, the distance here squared. So 35 squared plus 12 squared equals 37 squared. I'm going to go ahead and do that here. The very first step, I'm going to plug these numbers into my calculator because these are pretty big numbers, so I don't expect you to figure out how to do that right away, right? So go ahead and make sure you guys have your calculators out for these problems. We will be using them. If not, I would recommend you you can use your phone or your computer calculator, and that'll be useful too. That'll be helpful. So once we do that, you actually end up getting, let's see, I actually didn't do that one, but you end up getting 1369 on both sides. So by the tangent line to circle theorem, ST is tangent to circle P. Now we move on to the next one. So we have point B is the point of tangency. Find the radius R. So in this case, oops, I didn't want you to see that. So we're going to do the same thing, very similar to theorem 1. We're going to go ahead and find if this is if it makes a right angle, then we know, and these are 80 squared plus r squared equals this whole thing squared, then we know that actually, you know what, we're working backwards. So we do know that theorem 1 is true. So we're going to go ahead and use what theorem 1 tells us. So we're going to go ahead and use the Pythagorean theorem. And we have, since we don't know what r is, we're just going to go ahead and use that in our equation. So I have r plus 50 squared, quantity squared by the way, it's not individually squared, equals r squared, the leg right here, plus the other long leg, 80 squared. I'm going to go ahead and FOIL this one out, and I'm going to get 100 r squared plus 100r plus 2500 equals r squared plus 6400. You can go ahead and pause this video and try to do this on your own, moving the variables and the numbers to one side so you can solve for r. Okay, now that you've paused the video, hopefully I'm expecting that you guys have gotten your answer for radius. So r equals 39. Okay, so moving on to the last one. So the two more. We have RT is tangent to circle center at C at T. And RS is tangent to circle C at S. Find X. Well, we know that this is now moving on to theorem number 2, if you remember, right? And it shows that these two are congruent. The segments are congruent. So what am I going to do? Well, I'm going to go ahead and set them equal to each other, right? Hopefully you thought that as I was explaining this, or as I showed you this. And then you would go ahead and set them equal, and you'd say 28 equals 3x plus 28 equals 3x plus 4. So you get 28 equals 3x plus 4. You subtract 4 from both sides. 24 equals 3x, and x equals 8. I'm going to box in my answer, and that is your x value. Okay, so now these are some examples of common tendencies that I thought were pretty interesting to also know. So when we have 2 points of intersection, you have 2 circles where they intersect at this point, these 2 points. Versus when you have 1 point of intersection, this is an example of how they would look. You have 2 tangent circles. Versus if you have no points of intersection, these are called concentric circles. So think of this kind of like the target sign, right? Or the bullseye. It looks, or even a target, yeah, the target symbol, right? They have the same center, but they have no points of intersection. Alright, so this was pretty much all that we've done for 10.1. Hopefully it made sense. If not, go back and rewatch the video, and I hope you guys have a great day.